Good morning.
Good morning.
Sorry for the delay. I have issues with my connectivity. So if perchance I drop out during the class, just let me know. Just try and call me and find out if I can log back in. Right. Now, I would like you to take note that I have reorganized the notes for the programming part. And the reason I've done that, I've broken it down into small topics. Initially, it was all in one set of slides, but now I have broken it down. And I'm going to go over some of it during this class. Another thing I wanted us to do was, I want this class to be not to be the last class. I want us to have a break of 2 weeks where I expect you to actually program. So for the next 2 weeks, I don't want us to have class because I want you to get down and actually just program. So I want to cover most of the things that can enable you to program. I hope I will. And even if I don't, I want you to have that 2 weeks break. And when you come back, I expect you to have actually moved forward with your programming. Let me try and see up to which. Just hold on. You have programming assignments, I think, from number 1 to number 6. And I told you to do the first one, which you did. But remember that assignment 1 has 2 parts, which I think I will break down now to become assignment 2. So you'll have assignments 1 to 7. So right now you've done assignment 1. So when you come back, I actually expect you to have done assignment 2. And 3. We've done assignment 2, 2 and 3, which will now become assignment 2, 3, and 4. And also you have done assignment 4. Maybe the only one you will not have done is assignment 5. So really the 2 weeks is for you to go up to assignment, up to the last assignment, second last assignment. Okay? So the 2 weeks break is for you to program. And when you come back, please make sure that you have done all the assignments except the last one. So any questions that you may want to ask, please ask them today, because that means you will have all in your hands to program. Another thing I want to remind you, which I think I have been saying, but I have not been taking it seriously, is I want to know whether you have, downloaded this textbook I requested. Distributed Systems by Tannenbaum. I think it's edition, 4th edition. How many have uploaded that textbook? Okay, can see quite a number have uploaded it or downloaded it. Please go into your reading assignments and read that textbook. I have given you sections to read, and I will cover section 2.1, and I think it is 2.1. I think I'll cover 2.1 today, but 3. I think it's 3.4 and anyway, the ones that are in chapter 3, I want you to cover, and I want you to summarize what you have read, which then we shall discuss in class when you resume after your break. So chapter 3, you are to read and to summarize. And this is a group assignment. This is a group assignment. So as I said, you will prepare slides, and no more than 10 slides for each section. I think this is section 3.1, 3.3, and 3.4, something like that. So no more than 10 slides per section, and it's a group assignment. So make sure you do that during your break, your 2 weeks break. Yeah. So let me conclude with what we started last time, and then I will move on to other things which I'll quickly run through because I don't think we'll have enough time to explain them. But since they're in your notes, I think you will read a little bit more. But just know that you have the ability to program all those assignments when you finish class today. Okay, so we had looked at the first few primitives or functions that you need to program on the server side. Another thing I would like to remind you, I always have additional material. I always have additional material which you can look at for any topic that we have covered, or at least for some of the topics that I feel maybe you could benefit from additional material. I hope you have found the additional material document and you have looked at that additional material, if it's helpful to you. Now, I think somebody had mentioned about getting a link through WhatsApp for a textbook. I've also put those links in that additional material. There are 2 textbooks for which I've put links in that additional material. And those textbooks, well, they are online material. I don't know if they are textbooks, but they are online material. So please look for those links. Read whatever you find useful there. Not everything is useful for this course, but maybe in future. So please look for those textbooks. There are 2 of them that I've put in there. I've put in some videos, I've put in some documentation. Anything you think is useful for you, please make sure you look through that set of material. I think there's even one for programming, like an introduction. So if you are still having issues with programming, please look at those videos and any other that you may find online. Right. So now we are on the client side of programming. Now the client also creates a socket. We talked about this when we were talking about the server. The client also creates a socket and so uses the socket primitive. So I won't go over the socket again because it was done in the server side. So the same way you create a socket on the server side is the same way you create a socket on the client side. Now, another thing I need to mention, there is what is called, there is a manual, a Linux manual. Also, I've put a link in that additional material. Now, this Linux manual has all these commands that we are doing in class, and it has a detailed, what do you say, a description of each of these commands. So please look for that Linux manual in that additional material. So if you want to find out how any of these commands works, just type the command in that box and it will give you everything you need to know about these commands. Of course, some of it is very detailed, but just look for what is enough for you to program. So I expect you to use that Linux manual a lot when you're programming until you are very familiar with these commands. Another thing it will give you will be which files to include, because you will realize that most of these network programming, you have to include a lot of files. For each of the commands you use, when you look into the Linux manual, it will tell you which files to include. And I think another thing I need to mention is there's a textbook which I think I have mentioned as one of the core textbooks. That textbook will help you with programming. And I've actually said you read from chapter 1 to chapter 12, but most of it is actually programs. Beyond, I think, chapter 8, there are huge, huge programs in that textbook. So really, make use of that book during this 2 weeks break. Okay, connect. Now, the client, as we said, uses the connect primitive. If you're programming using TCP, then the client must issue the connect primitive to connect to the server. Now, notice that the connect primitive assigns a free local port number to a socket. So on the client side, you don't have to do a bind. Remember that on the server side, you had to do a bind, but on the client side, you don't do a bind because, as I said, the operating system will just provide that client with a free local port number. Free means that it has not been used. Remember, numbers range from 0 to 65,000. So the operating system will just look for a free one that is not being used by any other program, and give it to the program that is requesting to connect. Now, what is the format? The format is as given there. First of all, you expect a return value, an integer return value. So that's why the int is there. Then, of course, you have to give certain arguments to that connect command. And I think there are about 3 of them. So if you look in the argument sections, it says the first one is the FD, or the sock FD, which is the socket descriptor. So remember, you created a socket before you used the connect. And then the socket command returned a socket descriptor. So that's the socket descriptor that will be put in that part, the sock FD. Then again, you have the socket address, which, as we said, you have to preload this socket address with the right address, as we said last time. And in this case, the client program will have to load it with the address of the server that it wants to connect to. So there will be several statements before this connect command, which will be putting values inside that socket address structure. Then, of course, you will pass the pointer to that socket structure in the connect command. And then, of course, the socket length. You have to use the length function to find out the length of your socket. Not of your socket, of the address structure. Okay, so those are the arguments that are in the connect command. I think I've already said that. If you're using TCP, then the socket address, of course, will contain the address of the server that you want to connect to. Now, of course, if it is a datagram or connectionless, then still it will contain the address of the server that you want to connect to. But remember that this is not required. A connectionless client can send data to any server that it wants. But if it chooses to be tied to one server only, then it will use the connect. Otherwise, there is no requirement to use the connect when you're using connectionless. So here is an example. Notice we have declared a variable socket descriptor, and then we have declared a variable for the socket address called server, where you put the server address. And then there is that return value that there's a variable there for return value, I think, for the connect command. So the server structure, you put in the address of the server, as we said, and then you call connect. And notice that in the connect, you put the socket descriptor, which you should have used when you are creating the socket. So you put the socket descriptor, then you put the structure, the server structure that you have just loaded with the address of the server, and then you find the size of that data structure. And then, of course, you expect that there is some kind of return value that will be returned to tell you whether or not that call was successful. Notice in the return value, if the connect is successful, it will return a 0. If it is unsuccessful, it will return -1. So as I said last time, always check your return values to know if your command was successful or not successful, so that you know then what to do. You cannot assume that it was successful. Now, the connect command blocks the client and starts the connection process. Now, we already did that connection process, which we said was a three-way handshake. So when the client calls the connect, then the three-way handshake begins. Until the three-way handshake is complete, the connect call will not return. Now, of course, it may be non-blocking when you use it in the connectionless. Remember, I said you can use it for the connectionless. In that case, there will be no three-way handshake. So it will really be non-blocking. But if you use it in the TCP case, there will be that three-way handshake, and the process will be blocked until the three-way handshake is complete. Okay, so now the client has created a socket. The client has connected to the server. After those two commands, the client is now connected to the server. So any statement after connect, if your program continues to execute beyond connect, then you know that your client is connected to the server. I explained last time how the server will duplicate itself and pass that client over to a duplicate of itself. But whatever the case, the client is at that time connected to the server. So now, both sides, remember it's both sides can now use send and receive to transmit and receive data. So both the server and the client. But as we said, since it's the client that is the active one and has an active socket, remember the server has a passive socket. The client has an active socket. Usually it's the onus is on the client to do the first send. But both of them can now use send and receive to transmit and receive data. But they can also use read and write. Remember, this was designed along the file input-output approach that was used by Unix. So you can also use read and write the way you read and write files, okay? And then the connectionless one can use another version called send to and receive from. So the send and receive is for the connection oriented. The connection oriented can use send and receive, and also read and write. The connectionless will be required to use send to and receive from, because remember, connectionless does not connect to a specific server. So when they are sending, they have to say which server exactly they are sending to. So they have a different form of send, which is referred to here as send to and receive from. So those are the primitives now they can both use for sending and receiving. But remember that the onus is on the client to initiate the sending and receiving. So what is the format of send? Now, notice there that send has several arguments. So we'll go through each of those arguments in turn. Now, obviously, there is the socket descriptor. The SOCK-FD is a socket descriptor, file descriptor, which is for the socket that the client is using or the server is using. So that's the first argument. Then there is that second argument, buff. Now, buff is basically just an array. It's really just an array into which you will put all the data you want to send to the server. So that means in your program, you must create this variable, whatever variable and whatever name you give it, it doesn't matter, but it's an array. And in that array, you put the data that you want to send. And I think you are required to pass the pointer to that array. Then the third one is the length of your message, which is in the array. So again, you have to use size of to be able to find out what is, how many bytes have you put in that buffer that you're sending. And then the last parameter is for a flag, but typically you set it to 0. And if you read in that Linux manual, online Linux manual, it will tell you a lot about that flags and how you can vary it if you want. But typically you just set it to 0. So notice here, you are sending some data to the other program you're communicating with. Of course, when you call the send, you actually trap into the operating system because it is the transport layer that will actually do the send. So that buffer, whatever is in that buffer, will be copied into the buffers that are in the transport layer. And then the transport layer will remember, the transport layer is the one that creates the segment, puts a header, and all those things we talked about. So that's the format of the send. Notice it has a return value. And that return value, I think also you need to check it before just to confirm whether whatever you sent was actually sent. So here is an example. The first statement there creates a socket descriptor, and then it creates an array, as I said, of characters. Because remember, everything is sent as a stream of bytes. I think I mentioned that. And I think I'll put a link in your notes. I don't know whether it's this set of notes, I think. And I've shown you where you can read more about that stream of bytes, but it's really just a stream of bytes or characters. Now, notice that in this particular program, the message that this client wants to send is the one in double quotes. Get, so it's really talking to an HTTP server. So it's sending this message get, and then it says exactly what it wants it to get. So now it puts that message in the message buffer that it declared, and then calls the send command to send that message. So notice that the first argument is socket descriptor. The second one is the message. Of course, if you are aware of C, you can just pass the pointer by putting that variable name there. It will pass the pointer to that variable. Then there is the length of the message, which you find by string length, which is a function available in C, and then 0 as the last flag. We say it is typically 0. And that statement will make sure that that message is then passed to the transport layer and sent to the other program that it's communicating with. Now, of course, there are other forms of send. Let me just, the other forms of send, I just wanted to look at the return value. Now, if successful, the send returns a 0 or a value greater. Now, that indicates the number of bytes sent. So it will always return and tell you how many bytes were sent. And I think that is in the case where it doesn't send all the bytes that you wanted it to send, but it will return a 0 or a greater than, indicating the number of bytes sent. Now, of course, if it's unsuccessful, then it returns a 1, indicating that there was some error in the sending. Now, when you use the send, it basically just tells you that the transport layer has accepted that value, that message that you want to send. It does not necessarily tell you that the transport layer has actually sent it and that it was delivered. That is not what it means. It just really says that the value was accepted and will be sent by the transport layer. So no indication of failure to deliver is implicit in the send routine. Okay, so that's the normal send, but as we said, there are other forms of send. Now, the one that you would be interested in is the send to, because the send to is the one you use with the connectionless version of the connectionless, the client that is using a connectionless protocol. Now, in this send to, you have additional arguments apart from the ones we've talked about. Notice it has the socket descriptor, it has the buffer, and it has the size. Those three we have already seen in the other send. But now notice that it has the socket address. So if the connectionless client is sending data to a server, it has to say which server it wants to send this data to. Because remember, it's not a requirement for the connectionless to create a connection before it sends. There's no requirement like that. So ideally, this is the only time that the connectionless client says which server it wants to talk to. Which server does it want to send this message to? So now that socket address structure and the length of that address structure must be included in this send. So that's the only addition. The other send for the connection-oriented does not need to include the socket address because it already said in the connect which server it will be talking to, which server it will be connecting to. But for the for this connectionless, they have to, for each send, they have to say which server they want to connect to. And that means that they can talk to several servers. A connectionless client can send a message to server A and then next time send a message to server B, because each message is complete in itself. So just take note of that. And then there is that other send message version of the send, which you can find out more about, but most of those things are just similar to what you said. I think I've already explained this. And I've already explained the send to function that is used by the connectionless client. And I already talked about the return value. So that is the send. And on both sides, it works the same. Remember that both the server and the client are able to use the send. So that send primitive you talked about will be used by the server. It will also be used by the client. And the arguments, as we have said, remain the same for both the client and the server. Now, when we talked about the accept command in the last class, we said that the server, when it does an accept, it is given the address of the client that is trying to connect. So by that, of course, it will know the address of the client, and so it can reply. Now, the receive command. The receive command obviously is for receiving data, which has already been sent by the other party. So what are the arguments for receive? Again, you must specify which socket you are using to receive, and then notice that the buff is also there, which is, as we said, is just an array. So it's the array into which you want to receive the data that has been sent. So on the sending side, it contains the data you want to send. On the receiving side, it's an empty buffer into which the operating system will put the data that has been sent or that you are receiving. And then, of course, you must give the length of that buffer, and then the flag, which, as we said, is typically 0. So it's more or less the same as the send, only that in this case, the buffer is empty in readiness to receive the data that has been sent. And remember, there is no requirement for your buffer to be of any size. I think I said this when I was talking about the stream protocol. You can receive as much as you want in bits or in chunks, depending on your preference. Because as far as the client and the server is concerned, it's a stream of bytes. So you can read it in chunks or in sizes of your choice. So you may read, for example, in chunks of 100 bytes at a time, or 200 bytes at a time, or 2 bytes at a time. It doesn't really matter as long as you put there a buffer and you say the size of your buffer. But of course, you'll have to receive many times to receive all the data. If you decide to, if it's a stream of bytes of 1,000 bytes, and you want to receive them in chunks of 100, that means you'll have to have 100 or 10 different receive statements to receive the whole stream. So always just choose the size that you want to read your data in, if you're reading a long stream of bytes. But if it's not, then you can just read it once. So I think I've explained those arguments for the receive. They are quite similar to the send. And again, here is an example. It's just the same example that I think we had in the previous one. So here we've described a socket descriptor of type integer. Then we have 2 buffers. Notice that there is a first buffer, which is message, and the second one is server reply, and it's of size 2,000 bytes. And then in this particular case, the message that we want to send remains the same, and then it is sent. So assume this is the client. It sent a message to the server to get some document. And then after sending, then it issues the receive, because now the next thing is to wait for the server to reply. So notice what is in the receive is the socket descriptor, that buffer that it created for the server reply. And it's a good idea, I think, to zero that buffer just to ensure it doesn't contain anything really. I think it's important to zero it or to prepare it before you actually receive. So anyway, it puts there the buffer, and then it puts the size of the buffer. Of course, you could have used the size of function, but you just put the size because you declared of 2000 there, and then 0. And when that, of course, that is a blocking call. The receive is a blocking call in that it will not return if there is nothing to receive. So if there is nothing yet to receive, your program will be blocked until something comes from the other side. So that is sufficient for receive. And this is for the connection oriented, remember. So data which is received is copied into that buffer. In this case, our buffer for receiving is server reply, which was declared up there. So data when it is received is copied into that buffer. If data is not available, then notice that the receive call blocks. It blocks the caller until data arrives. Now, for datagram socket, it returns the entire datagram that was sent, because the datagram sends data in each data item is independent and is complete in itself. So it will return the entire datagram message, which means you have to have a buffer that will contain the whole datagram, provided that the datagram fits into the specified buffer. So in the case of when you're using the datagram version, you have to provide a buffer space to contain the entire buffer, to contain the entire datagram. Now, other forms of receive, we'll just look at the receive from, which is used by the connectionless client or server. So the receive from, as we said, is quite similar to the receive from for the connection oriented, only that now you add the address. And again, this socket address is empty. It's empty because you don't know who you are receiving from. Remember, there were no connections created. So you really don't know which client or which server is going to respond. Remember that the client can talk to several servers. The connectionless client can talk to several servers. So when it is receiving, it doesn't know which of those servers it's receiving from. So it must always provide a buffer where the operating system or the operating system will take the address of the server that is providing this message and put that address in that data structure. And it will also return the address length. So again, you must provide a variable where the operating system will put the address length. And remember, we said the address length is of type socklen underscore t. So you must create a variable of that type, because that type is already predefined. And then you put that variable in your receive from command. So that is basically the receive from, which is used by connectionless. As we said, quite similar. The only thing is that you have to add the sock address and the address length variable so that your program or your client will know which server responded. So I think I've already explained those variables. Maybe you can read later, but I think I've tried to explain those variables that are used by the connectionless server or client. Now, the return value, if successful, the return value is always 0 to indicate that it was successful. And if unsuccessful, it will also indicate. Now, notice that in this case, if successful, it will return the length of the message or the datagram in bytes. So when you receive, it will tell you how many bytes you have received. So the return value should really, I think it should be an integer, which will give you the value of what has been received. And I think it's also a predefined value, or you have to define just an integer to receive that value. Okay, finally, the close command. So remember that the client and the server will be communicating using receive. They will be using send and receive several times before they close, depending on what they are saying or depending on how much they need to send. But this will be a loop in your program. Send, and then it goes to receive, and then loops again back to send, and then receive. So this will really be inside a loop. So that will happen as long as there is data to send and receive between the client and the server. So once it breaks out of that loop, then now the next thing would be to go to the close command. So for the close, the format is simply close and you put the socket descriptor. So you're basically asking to close the socket that is attached to that descriptor. And there's not much to close. As you see there, you have to just close in brackets the socket descriptor, and of course you expect a return value to tell you whether or not the socket has been closed. And again there, you have to be aware that there is that four-way handshake taking place as the close command is done. So if successful, it returns a 0. If it's unsuccessful, then it will return a -1. So I think that brings us to the end of these primitives. I think once you start programming, you will realize that you will need to come back to this set of notes again and again, or you will need to go to your Linux manual, the online Linux manual, just to remind yourself of how these functions or primitives work. So any questions? Any questions? And you will need to use these a lot to just understand the general way in which the client and the server use these commands. So shall I then take it that you're okay with those commands? Yeah, there's a question. Edith and Jerry. Yes, Edith first.
Yes, I wanted to ask about the assignments. You had said we have like two sets of assignments. We have the reading ones, and then
Just
we
increase the volume. I can't hear you very well.
I'm saying I wanted to ask about the assignments. Were you talking about the programming assignments? Because I wasn't able to hear you clearly. when you are saying we should do all except the last one.
Okay. Let me stop sharing and just try to share that assignment, because I think it's up in your classroom.
Sorry, may you repeat?
No, I'm trying to project it.
Oh, okay.
Can you see it?
Yes.
So the last time I projected this assignment, I explained it, and I said you should do up to here, up to there. Actually, up to here. Okay. Then I said that this one you would have to wait. This one you would have to wait until we have done the work. Until we have, that is today. We have finished the whatever you need for programming. So as I said, I will make this assignment number 2. I'll make this assignment 2. So really up to today, unless of course you've been programming in the background, which will still be okay with me, you have done only assignment 1. So now this document has several assignments. So now there's assignment 1, there's assignment 2, which I'm changing now to assignment 3. So that will be assignment 3. And this assignment 3 expects you to program the iterative connectionless, iterative connection-oriented versions of this program. Remember, you have created a monolithic type of program in assignment 1. In assignment 2, you're supposed to break down the program into 2 parts, client and server. And you are to run the client and server on the same machine, right? So that's assignment 2. You take the program that you had already done, break it into 2 parts, the client part and the server part, and run the client and server on the same machine. Now, assignment 3, you are to run the programs on different machines, at least 2. Client is on machine 1, and client and server is on machine 2. 2 different machines. And you are to take that program and you are to program the client and the server using iterative connectionless, which means they both use connectionless. And then you have to take the same program and convert it into a connection-oriented version. Take the same program, convert it into concurrent connectionless. Take the same program, which program? The same program, this one in assignment 2, or the one in assignment 1, whichever way you want to look at it, and create 4 versions of that program using those approaches, which I'm just about to explain in a short while. So that's assignment 3. Okay. So that's assignment 3. Then there is assignment 4, which is a different program. So assignment 4, you're supposed to create a simple calculator. So now it's a calculator program. So assume the calculator is on the cloud and you want to use the calculator. So you want to send the calculator some data and ask it to add 1 + 1 or 2 × 3, you know, whatever. So the program is not on your client machine, it's on the server side. So you send the server calculator a message and ask it to calculate, and it returns to you a value. So that is assignment 4. I don't know if I've explained which version it should be, but ideally you're supposed to do the same versions for this one, for assignment 4, these 4 versions here. Okay. Then now there's assignment 5, which means you find this is assignment 5. Is it 5 or 6? Assignment 5. and this is 6. Now, so assignment 5 is you write a client program that can talk to any web server. So you're not to program the web server, you program the client part. And then your client can talk to any server on any machine, any web server out there. So maybe you should find, I don't know whether YouTube server, any server you want to find there, out there. And use it to download pages from that server. So you're not using the browser this time. You're creating a kind of a browser, a mini version of a browser. That's really what I want you to do in assignment 5. So I don't want it to be a fully fledged browser. I just want you to create a client program that can ask for something from a web server and get it. And we will look at that web server, whichever page you are trying to load, we will actually go and look at it and see whether that is what was loaded, was downloaded. That's assignment 5. Assignment 6 is about distributed programming, which you are going to do using RPC. So this one, we haven't done anything yet. So this is the only one I'm saying I don't expect you to do. So, as I said, from today's class, you should be able to do all the way to assignment 5. That is a lot of programming you are going to do. But remember, the bulk of the program you have already done in assignment 1. And I hope you did it so that you don't have to go back in it. So right now, you are just to insert those statements we've gone through, the create socket, connect, send, receive, into your program. So it's really not that much, assuming the other parts of your program are working. Is that clear now?
Yes, it is clear.
Okay. So I'm giving you 2 weeks to program. Any question?
I have a question.
Yes, Jerry.
It's about the receive from primitive.
You forgot.
No, I'm saying it's about the receive from primitive.
Okay. You want to ask a question on that?
Yes.
Yes, no problem.
So you had said that, had you said that when the client is receiving the response or the server, then it has to know the size of the message so that the buffer can fit the entire message inside.
Yeah.
So how does it know the size of the message beforehand?
Good question. Very good question. Right. I think I will, okay, so let me just stop sharing because it has nothing to do with that. Now, there is something called the application layer protocol. First of all, let me bring to your attention. We have now done all the way from layer 1, which I believe you did in your first year. You have done layer 2 when we did the data link and when we did the local area network. We looked at the 2 layers that every local area network should have. So basically, you've done layer 1, you've done layer 2. We did layer 3 when you were doing the IP layer and the IP addresses, that is layer 3. Layer 4 is what we have done in this course. And now, if you're using the internet, then the only layer left is the application layer. And in each of those layers, there are protocols, right? So now, what you're really asking is about the application layer protocols. And remember, there are very many application layer protocols. HTTP being the most well-known. But there's SMTP, there's Telnet, there are all those application layer protocols. So now we are getting into the realm of application layer and application layer protocols. Basically, a protocol defines the rules for communication. So obviously, if it's a client is communicating with a server, they will have to have their own set of rules for communicating. They just need to know. Apart from this stream one, which we said is just a stream of bytes, where you don't know where one stream begins and ends. But of course, you will know when you don't receive any more data, or at least you will not know where the stream begins and ends. But in the case of the connectionless, you just need to, there needs to be some agreements in terms of communicating. For example, remember I have just given you an example here. Let me go back to that example. This one. This is part of the application layer protocol for the HTTP. In other words, when you tell a server, web server, you want to get something, there is a standard form in which it is written. First, you have to use the command get to say that you want to get something. Then, of course, when you're writing this client program, you'll have to find out what else does the client have to say in order for the server to understand what the client wants. That's an application layer protocol. What do you send? In what order do you send it? So that when the server receives it, there is no misunderstanding between the client and the server. So the client and the server also have their own protocol. So if I'm to send you a message, what should be in that message? How long should it be? What should it contain? So just assume there's an application layer protocol that defines all that. And so you will know. You will know. All these things, for example, are programmed into the browser. The browser knows what the server expects and always sends it and knows what kind of a reply to get and what that reply means. So there is also an application layer protocol, which defines the communication between client and server. And that means that in the programs you are writing, you also need to come up with the application layer protocol. When you want to get a service from your server, how do you say it? What do you send? What is in that message you are sending? So the first thing you need to sit down when you're converting your program into client server is to define this application layer protocol very well. You must define it very, very well. And please make sure you include it in your submissions. Remember, there are two things you have to include: the design of your program and the application layer protocol. So I hope I've answered you, Jerry.
Yes, yes. Thank you.
Yeah. Okay. Now I want to quickly go through several things. I don't know if I'll even manage to do that, but I'll choose the most important. So now, this comes from that textbook that I asked you to read. So I just summarized some of the important things that are in that that are in that section. Now, as I told you, I broke up the set of slides into these topics. My hope today was to at least talk about everything up to there. That was my hope. I'm not sure it will be achieved, but that was my hope. So anyway, we finished with that. That is what we finished with. I want to talk a little bit about the client-server model, which comes from that textbook. And so I will just go over it and point the important things. So this particular set of slides is about this. Each of these is in its own set of slides. So let me just, there are several things I want to talk about. In fact, there is just this that I want to talk about. I want to emphasize it because, as I told you earlier, I've realized that students program and they don't quite understand what is the client-server model. But of course, I always tell them to read that textbook, and they read and they don't get the important things. So this time I've decided to put it in slide format. So let me just point out the important things. I think the ones I have put in red. Now it says a server is a process implementing a specific server. Notice that a server is a process. Because I know most people, when you ask them what is a server, they will think of the machine. A server is the program running on that server machine. It becomes a server machine because it's running a server program or process. Now, because we are doing programming, we are actually talking about the server process itself. So it's a program that's running and providing a specific service. Now, service could be anything. So for example, you can have a file service which offers you the service of opening, reading, writing a file, closing a file. So it provides you with a file service. But what exactly does that file service entail? It entails several things like opening, reading, writing, and closing the file. Okay, and of course, there are many more operations. So a server is providing a service. And the way you request for that service is specified by the interface. So that interface is the one that has all those commands, like I said, read, write, close, open. So you must distinguish between the service and the interface that the service provides. And I think I've put that, it was emphasized in that textbook, and I've also emphasized it here, that you need to be able to distinguish between the service and the interface that is provided by that service. Okay, so that's the first thing. Now, a client is a process. And again, I need to emphasize this because some people think that the client is the machine. Of course, it also depends on where you are coming from. If you're talking about programs, the client is the program that's running on that client machine. So in fact, it is a client machine because it's running a client program. It's not the other way around. It is the program you're running that makes that machine what it is. So again, the client is that process that needs to request for a service from the server. And notice, how does it request a service? By sending it a request. And that's why we are talking about this send and receive, open, socket, and so on. So the client will send a request to the server. As we said, the server must be able to understand that request fully. That means they must have an agreement on how do you request for this service, like we've seen for the GET. So it sends a request, the server receives that request, and subsequently it waits for the server's reply. So the server receives the request, understands the request, gets whatever the client is asking for, and sends back a reply. So from the time it sends a request, from the time a client sends a request, to the time it receives a reply, it will be waiting. So you've already seen that program where we had a message sent, and then immediately after the send request, there was a receive message. Okay, so please take note of that definition. It is a process. One is offering a service, one is requesting for a service. Now, the client-server interaction is also known as a request reply. Based on what you said there, the client sends a request, the server sends a reply. Now, so you are familiar with this. I believe if you've done the RPC, you're familiar with this diagram, but just notice that the client sends a request and the client sends a request to the server does some processing, and once the processing is done, it sends a reply back to the client. And meantime, the client waits. So at this point, the client uses the send primitive. Okay, so at that point, it uses the send. Then it uses the receive. So from here, immediately it may use the receive. It may issue the next statement after send will definitely be received. But since we don't know when the server will send the data, it may take a while. This receive, as we said, is a blocking receive. So from here, from the time the client issued a receive, it will block all the way to the time when the message is returned. And then it will be unblocked. Right. So we talked about the request reply protocol. So let's go through it in detail, because sometimes it may look obvious, but it is not obvious. Now, when a client sends a request for a service, notice the things that it does. One, it packages a message. Remember, we've just looked at the send primitive, which has a buffer, a message buffer, into which it puts some data before it sends. So that's what we call packaging the message. So it packages the message. Now, in that message, what is in that message? So underneath is, what should you put in a message? One, you must identify the service. Assume that the server is providing, for example, a file service. As we said, the file service has an interface, one which is open a file, then of course, read a file, write a file, and close a file. That's what is in this file service interface. Okay. So when the client is sending a request message, does it want to open a file? Does it want to read a file or write it or close it? What does it want? It must identify the service. So it must say whether it wants to open, read, write, or close. Now, along with that, it must provide the necessary input data. For example, we've just talked about send and receive and the arguments. Each of these functions has some arguments which are specified by the service. So if you are saying you open, you say which file you want to open, which mode you want to open it, and so on. So in this message, you not only identify the service, but you also provide the data that will form part of the argument. All the data needed to open a file, or all the arguments needed to read or write a file, will be put in that message, in the request message. It will not be sent in bits and pieces because it's a complete request. Now, let me give you an example. If I want to send somebody to the shop to buy me something, I will not only give them the money to buy, but I will also give them a list of what I want them to buy. That's the only way my request will be complete. I give them everything to make sure they bring me back what I want. So I will tell them what I want to buy. I will give them the money I want them to use to buy, and maybe I'll give them the fare if they don't have fare. So all those things will be part of my requests to them. So treat your server in that same manner. When you want to ask a server for a service, make that request complete. Now, so now we go to the server side. When the server receives a message, the server, of course, the server will receive a message. It will have to use that receive command to receive that message. It will then process the message. Process the message here means, as I've said, if I want to send somebody to the shop, I'll give them the money. I will give them the list of things I want to buy, and I will give them the fare, or if that is relevant. Now, when the server receives the message, it has to unpack this message. It has to know, how much money have I been given? What is the list of items I have to buy? And how, well, of course, this fare doesn't make sense here, but let's just use the money and the list. So the server has to unpack that message, process it. So if it's a string, it has to tokenize it. It has to find the different parts of that stream of bytes. So that's what I'm saying. When you are writing your program, make sure that your program defines every aspect of the communication. And I have run out of time, but I think that is the most important thing. That I think for me is the most important thing. And so let's do this. Let's just okay. I think there's one more thing I need to say, which is I think I'll just show you where it is, and then you go and look for it, because I want these 2 weeks for you to start programming. There's no way you are not going to program. I think the other thing I want to bring to your attention, and please just bear with me, on this one. I think it's the last thing I'm going to talk about, and I'll take a very short time. I want to talk about the iterative versus concurrent server, so that you know the difference as you program. Remember, I've asked you to program concurrent versus iterative server. Okay. This is a slide for iterative servers. This is the slide for iterative servers, but you look at the one for concurrent servers. I want to bring to your attention something referred to as the conceptual server algorithm. You notice here it says conceptual server algorithm. If you look into that textbook that I have, the other textbook apart from the distributed systems one, there's another one I think I recommended, it's in your reading assignment. Inside that textbook, remember I said you have to read from chapter 1 to chapter 12. But there's a chapter in that book that talks about the conceptual server algorithm. for the connectionless, for the iterative connectionless, iterative connection-oriented, and so on and so forth. So you go and read those conceptual algorithms. But let me just go through this one so that you understand what a conceptual algorithm looks like. And please, in those 2 weeks, if you have any issues, you can always get in touch with me. I'm just around. I've not gone anywhere. Okay, so the conceptual server algorithm just tells you the steps that you go through when you're writing your program. So in this one, remember it's connection oriented. It's connection oriented, which means it uses connections, but it's iterative. I think the important thing I want to talk about is iterative versus concurrent. So notice you create a socket, then the server binds that socket to a well-known address, then it places the socket in passive mode, all those things we've talked about, then it accepts a new connection. Now, notice when you talked about accepting, we say that whenever you use accept, you get back a new socket. But now, if you are an iterative server serves one client at a time. That's what you mean by iterative. It serves one client at a time. So if this is your server, and the server has a queue of requests, remember that it's for connection requests, it means it will get one connection request, service that client in totality, which means it will receive all the read-write requests from the client and then close the socket before it goes to pick the next connection request. Now, remember when it picks the first connection request, it gets a second socket. And that second socket is the one that talks to the client. So they will communicate with the client. In other words, it will suspend being on this queue for the time being. So it will talk to that client until they finish. And then this connection will be terminated. Then that server, and when the connection is terminated, remember that this duplicated process is also terminated. Please don't forget that. This process, whenever it finishes its job, it must be terminated. Then the client will go back here, the server will go back here and pick the next connection request. With that connection request, a socket will be created. Then that socket will connect to that client. So the server will talk to this client until they finish and they terminate this connection. And this process is also terminated. Then the server goes back here and picks the next connection request. That is what an iterative server is. So this conceptual algorithm is just to give you an idea of how that program should run. So notice when it receives, when it accepts a connection, it gets a new socket. And then with that new socket, it goes ahead and services the client. So it will read a request from that client. It will process the request, which means understanding it and doing what the client wants. Then it will create a message. It has to package a message which it wants to send to the client and then send that reply. And notice that this is repeat. So this will be done in a loop, inside another loop. So it will do it loop all the time and read all the requests from that client. When it finishes, then when it gets out of that loop, then it will close the connection with the second socket. Remember the second socket that was returned. Then from there, it returns back to the queue for collecting the connection requests. So when you are writing your program, make sure you obey these conceptual algorithms. So you need to read those conceptual algorithms until you understand them. There is really nothing complicated about them. Most of the things we've covered. Only you need to know that in an iterative version, it services one client at a time. In the in the concurrent version, it serves multiple clients at a go. And so you will find that when it accepts a connection, as we said, it will create another duplicate of itself to do this part. And then it will loop back and accept. So this main master server will always do this, hand over the new socket to another version of itself, which means within here it must duplicate itself, pass that socket to the new version of itself, and then return. So now, after receiving the first request, there'll be two programs running, this master and this one. If it gets another accept request, it will do the same thing. It will duplicate itself. It will hand over that request to another client, and then it will return here. So I think with that, I want you to start programming. 2 weeks is enough for you to figure out what you can do and what you can't do. So let's meet in class, God willing, after 2 weeks. Any questions? Any question? Yeah, Diana. Did you have a question? Yes, I'm expecting you to talk, Diana, but I'm not hearing you. There's Makoa also.
Can you hear me?
Yes, I can.
Would you please add me to the classroom?
Where have you been all this time, Diana? In fact, I saw you today and I was wondering whether I've seen this name at all. Where have you been?
I've just confirmed that I need to finish this course.
Oh. And you think coming into the course 3/4 way is okay?
No, it's a request.
Then write me an email on that one.
Okay, thank you.
Makoha?
I wanted to ask, is the best implementation for the client server model if we use the HTTP, okay, you use HTTP server method to communicate between the client and the server, where we use requests like get requests, post requests, put requests?
No. Let's stop. I'm not even sure why you're asking that question. I want you to use the send, the receive, the connect. Those primitives I've just gone through.
Oh, that part I get. It's for example, for the client, when that buffer that you will send to the client will send to the server, the format for that message, it should take the format for a normal HTTP message, where it usually has it will use the sockets, and I'll create the sockets, connect it, but now the string that will be sent, that's the part I was asking about.
Yeah, that's a good question. You see, I've already talked about the application layer protocol.
Okay.
So let me use this set of slides to just explain what I think you are asking. If I'm answering the wrong question, then you'll also tell me. Right, so let me just use it. Let me just draw it here. So if I'm getting you right, this is the question you're asking. You're saying that server and client are talking. First of all, I think one of the first things you have to figure out in this program you are writing, what are the services that the server is offering? What service is it offering? And what is the interface that this server is providing? Please remind me what program you're writing. I've forgotten. What was the program you're supposed to write?
It was a program on showing a book catalog. Most of the details you'd left to us, but it should be able to display the catalog, add an item, purchase an item.
So I've already given you the interface.
Yeah.
I've already I highlighted what the interface should look like. But it's an online bookshop, I guess.
Yes.
It's providing a service, an online bookshop service, where of course there are different things you can do. So that's really what you're doing. So the first thing you will have to do is to define what service the server is offering and what is in the interface, which, as you say, I've already given you. So let's assume one of them is to list the books that are there. You want to know which books are in this bookshop. Okay, so now the client wants to request this service of listing for the books in that bookshop. So the question is, what should the client send to the server? Okay? Remember, they have created the connection and everything. So first of all, as we said, it must identify the service. So that service, of course, will be list. So in that message, you have to say list or whatever. I mean, that now depends on your protocol. If your protocol identifies list by the variable L or a letter L or R or whatever, that is your choice, or list, it doesn't matter. That's part of your application protocol. You have to say, how does the client identify to the server which service they want? That is a choice you make. What else should be sent in this list? Maybe let me just assume. I'm not sure how you've implemented your application, but let's say I want to list all the computer science books, because I believe that in that library or in that bookshop there are different types of books. So let's say I want to list, but the argument maybe requires me to say which type of books do I want to list? Are they computer science? Are they what or what? So that's part of the argument. So notice this is the identifying of the server. This is one of the arguments. Let's just assume, and I'm just making this up as I go because I don't know what you've implemented, but I presume you've implemented something. So in the argument for list, maybe I have to say which type of books I want listed. So computer science. How many? The first 20, the first 30, or what? I don't know. Maybe, so I'll put a variable. I want the books to be listed to be at most 30. So maybe that's the next variable I'll put in my message, 30. I don't know, but it depends on your application protocol. So what I'm saying is this, that when the client is sending the message to the server, because it's the server that will execute this function, remember? So you have to put everything necessary for the server to execute this function. Now, how you separate these things, it's up to you. You may separate them with a full colon, with a comma. It doesn't matter. Remember, it's the string of bytes. So you will just put them in a message and send them. Now, when the server receives, it must take this whole string and it must know where does the service that is being requested start and end. So if you decide, it will start from the first letter up to where there is a comma. So when the server is looking through this string, it will look for this string up to where it finds the first comma. And it will know this is telling me which service the client wants. Now, following that comma, it will tell me which type of books it wants listed. So it will read from this comma all the way to the next comma. Assume the separator is the comma. It could be anything. So it will read this string, and then it will interpret what exactly is the type of books that the client is asking for. Now, after this comma, then maybe it will say, okay, that I know how many, at most how many books they want listed. So it will read this. And remember, it reads it as a character, not as a value 30. It will read it as a character and turn it into an integer. So it will read 3 and 0, turn it into an integer to find out how many books it wants listed. So if I'm understanding your question correctly, how you separate the different items in this message is part of the application protocol. Is that clear?
Yeah, that is clear.
Yeah. So you must define your application protocol correctly for each and every service. And then, of course, you have to define when the server is responding to the books, are they going to list for every book the title? Are they going to list for every book the author? What are they going to list? And so if there are 30 books, assume there are 30 books, for each of the textbook, what is going to be listed? Title, author, and whatever. And how will the server separate each of these so that you know from here to here is the title, from here to here is author, from here to here is date of publication? How will you know that? That is part of your defining your application level protocol. So before you start programming, please spend time on this one.
Okay.
I know most of you like jumping into programming, but it's important. Now, of course, now when you write your server, that part we are saying the server processes this request. That will be part of identifying what is in the message. One process, it will remove each of these things or separate them. Then it will call the function and execute it and get back a result, and then package that result again. So if it is title first, then author, then date of publication for the first book, then maybe full column, then title, then author, then date of publication for the second book. If that is the agreement between client and server, then the server must take all those books and package them into a message that it can send. And when the client receives, it will know I'll get the title first, then I get the author, then I get the publication date. Then when I reach a full colon or a semicolon, then I know the details for that book are over. So that if something is packaged the wrong way, they both know. Or at least the client can say, look, I'm lost. I don't know what you sent. I can't interpret it. So spend time on defining your application level protocol. Take time to define the service and the interface that the server offers to the client before you start programming.
Okay. Thank you.
Yeah. So as I've said, 2 weeks is enough for you to program. In fact, maybe not even enough. But if you don't spend these 2 weeks programming, I don't know when you will get time. How many more weeks do we have?
Maybe
Nobody
4.
knows how many more weeks we have?
Maybe 4 for
Okay.
this month, so that we start exams next month.
Okay. So at least you have 4 weeks. Please use those 4 weeks to program, because remember, I will create space at the end of the semester for each group to come and explain their program. So it's not just enough to program. I will demand of you that you explain to me your program. And I don't want to hear this thing of, oh, I didn't program this part, so I can't explain it. Be involved. Delve into this thing and be involved and program. Right. Shall we stop there? Any questions? As I said, I'm not far away, I'm just around. So if you have any issues, please get in touch with me. It's a group assignment and you all have to participate and you all have to know. And then another thing I would like to remind you of, for each group, you must say who participated, how they participated, which part they actually programmed, or which particular application they actually programmed. Whether it's the connectionless, iterative, connectionless, concurrent, or all those versions I've asked you to program, or how you divided up the work. So as you submit, you will tell me who did what. But each one of you must be ready to explain at least one program, of which I can decide to choose at random. So don't just go and program one program and then you say, me, this is the only one I know. Just make sure you do your programming. And now you realize why I told you to program the other parts of the program early. Because the only thing you need to add into these programs are those connect, socket, all those, just those few primitives, and maybe the application level protocol in terms of packaging the message and unpacking the message on the server side and so on. But the bulk of the program of how the program works, you have already done. Right, so we stop there. Anything I have not explained and you need to explain, please read in your textbook. When we resume, I will explain some more what I have not explained. But I think you get the logic. Those conceptual algorithms, please read them and understand them. Any logic that doesn't make sense? And another thing, you can either do the concurrent server with processes, you can do them with threads, you can also do them with something called asynchronous I/O. So far, I know you know about threads and you know about processes. So you can use processes and threads, which means you can make very many versions of this program. One, you may program the concurrency with processes, another one you may program with threads. The asynchronous I/O I will explain when we return. Okay. So I think we'll stop there, unless somebody has a question. Michael, please send me a message and remind me to include